starting version. Postgres 8.3 is where I really got interested in Postgres because it fixed a lot of major architectural issues in the performance of the database that made it much more practical to deploy on bigger systems. So the performance of just about everything is significantly better than there's also part of the reason for that performance gain is there were a lot of internal changes under the hood that shifted around things that you can't really adjust easily later. So there is a tool available initially in Postgres 8.4. It's gotten much more serious in Postgres 9.1 called PG Upgrade. What PG Upgrade does is it lets you make a copy of the database and upgrade it to a newer version without having to dump and reload the entirety of the data. So it takes upgrading to a newer version of Postgres from something that can take hours or days on a big database to something that should only take minutes. You still need to test, you still need to do QA, everything else, but the actual mechanics of the upgrade itself are pretty quick using PG Upgrade. The trick is, because there are all these major internal changes from Postgres 8.2 to 8.3, you can't use PG Upgrade on earlier versions of 8.3. So the Postgres development team is trying very hard that you can upgrade using PG Upgrade from 8.3 to any later version, possibly with intermediate steps at some point, but you're never going to be able to dump an 8.2 or 8.1 database and do it directly. You're going to have to do a dump and reload. So there's a third thing to be concerned about, which is that one of the more external changes that got made in Postgres 8.3 is related to data type casting. Casting is things like, I've got something that's a text field, but it's a number. I want to change that to be a real number instead of text that just happens to hold a number. It was possible in earlier versions of Postgres to be pretty sloppy with that stuff, and the server would maybe guess about it and go off in its merry way. A lot of that behavior got clamped down and wasn't happening anymore. So if you develop an application on something earlier than 8.3 and you move it to 8.3 or later, it's probably going to break. It's one of the most disruptive upgrades that's happened. It's certainly the most disruptive upgrade in the last 5 years of Postgres. Or maybe the thing to realize then is if you start on 8.3, you're not going to run into this casting problem when you try to upgrade later. You're going to get better performance from day one, and you're also going to be able to use in-place upgrade. So the way I try to explain to people is every day that goes by that you're running a Postgres 8.2 or earlier database, and your database is getting bigger, you're making the scope of the upgrade problem coming one day bigger too. So you need to start planning about that because a lot of these older versions are falling off of the list of officially supported ones in Postgres as well. So the availability of security patches and that sort of thing gets a little bit sketchier. You'll always be able to get them. The question is whether you'll get them for free from the Postgres community or whether you're going to actually have to pay somebody to do the work of doing it in older versions as well. So if you're starting a new project and you're not starting like weeks to 8.3, you're basically saying I want a taste of this terrible problem. One of the reasons people tend to start with an earlier version is that's the version that comes with their operating system. Up until recently, for example, a lot of environments run PostgreSQL 8.1 because PostgreSQL 8.1 is what comes with Red Hat 5. The things derived from that Hat 5. Part of the theory on that is, well, I won't be able to get support if I use a newer version of Postgres. Or, well, the versions that come with Red Hat go through more QA, and those are probably better than whatever ones I can get from the Postgres site. So all these things are wrong. In fact, the person who's worrying about the Postgres packages for Red Hat is also a member of the Postgres core development team. It's the same set of people doing all this work is what you really should realize. The people who are doing the packaging, whether you get the package officially from Red Hat or whether you get it from the Postgres Yum repository or something like that, they're not identical in all cases, but it's all the same people, the same QA process that they're going through. There certainly are advantages to getting Red Hat support and having that stuff available, but you shouldn't say, this kind of goes back to the theory I was mentioning backwards before. If you start on something earlier than 8.3, you're guaranteed to run into a bunch of these problems. If you say, well, I won't be supported if I use an earlier version, you're saying, well, I'm going to pick a problem that I might run into and prioritize that over a problem I'm definitely going to run into. So it's really not a great trade-off to make. Luckily, this situation has gotten better recently. I believe Red Hat 5.5, maybe it was 5.4, one of the relatively recent versions has now added PostgreSQL 8.4 as one of the official options. So instead of installing the regular PostgreSQL package, install PostgreSQL-8.4, and bam, it's available out of the box. So that has taken a lot of the pressure off of installs that I deal with who are kind of Red Hat centric on things. So if you're not aware of that and you are running on Red Hat stuff, you can go get 8.4, and there's even some work moving forward now to make it a little bit easier to take advantages of features like PG upgrade, which do require that you have two versions of Postgres at least temporarily installed to work properly. So 8.3 above for anything new, or you're asking for it is basically default configuration. I apologize for the links. All of the links on this thing just changed to barely readable text right before I did this, which is annoying. All of the slides for the conference, at least from the people who present here well enough to know the drill, normally get uploaded within a day or so after the presentations get done. So if you look at this slide, I can't read that right now, the conference website will have a version of this whole set of slides on it not too long from now, and then you can go click directly on it to go read the slide. Default configuration. Some people think, well, the default configuration for PostgreSQL surely is intended to be a useful default configuration, right? Well, no, that's wrong. The default configuration for Postgres is absolutely terrible and useful for almost nobody. So you might ask, well, what the hell? Why are Postgres developers such goddamn morons that they make the default configuration useless? It turns out that we blame the Linux kernel developers for this mostly. There are parameters in Linux, and this is true for all the Unix-derived operating systems. I'll just pick on Linux because I know the exact details on it. So all of the Unix-derived operating systems have this concept of shared memory. It's a block of memory that you allocate that then lots of different processes are going to talk to and all use a portion of. So when you start up Postgres, it allocates a large block, or it can allocate a large block of shared memory for things, and this is actually where all of the data that gets cached in the database is stored at. So all the clients that are floating around there can get access to it because it's in shared memory. They all can get to it. Right. The reason why the Postgres developers like this and why most reliable database configurations use this is having shared memory like this has some significant advantages as far as being able to protect clients from one another. And if a client does do something really terrible, like for example,